Okay, in this lecture we're going to talk about graphing rational functions and lay out a procedure by which we can just follow through and get all the information we require to get a reasonably good graph of a rational function. Alright, so again, a rational function is a polynomial, alright, divided by a polynomial. Okay, so both of these are polynomials. And we're going to work our way through the steps. First, we're going to identify the domain of the function and therefore any vertical asymptotes that are going to exist. Of course, the vertical asymptotes are going to come from the time when q of x is equal to 0, and that's going to produce that. That also comes from what our domain is. Okay, we're then going to find any horizontal or oblique asymptotes. And in the last lecture we looked at how to do that. We're going to find any points where the function crosses the y-axis. That's the y-axis intercept. We're going to find the x-axis intercepts by solving f of x equals 0, and these are actually just the zeros of the numerator p of x polynomial. So we're going to look at finding zeros for a polynomial. And we're going to determine if the graph will intersect its non-vertical asymptote, because sometimes it can. And of course a horizontal asymptote will have the form y equals b, and a oblique asymptote will have the form y equals mx plus b. So we need to solve which one of these it's going to be to see whether or not we actually get an intersection point. Alright, and we're going to plot any extras, alright, that is points as necessary, and we're going to complete the sketch. Alright, now in this particular case we have that y equals x squared minus 2x minus 15, x squared minus 3x minus 4. Alright, and you'll see here that we can actually factor this. It might be a more helpful form, and we can actually factor this into factors of negative 15 add up to negative 2. So let's see what they'll be. I'd say 5 and 3. And of course the large one will be negative, because that will give us the negative 2x. Divided by, now can we do this one, factors of negative 4 which add up to negative 3. 4 would be 4 and 1. And we'd need a negative 4 and a positive 1. So we actually have been able to factor the numerator polynomial and the denominator polynomial. So that leads us to step number 1. The domain of our function is the values that this can't have. Now notice we can't have x can't be equal to negative 1 and x cannot be equal to 4. Well, that will cause the denominator to go to 0. So we'll have everything from negative infinity to negative 1, and we'll have from negative 1 to 4, and then we'll need from 4 to infinity, and that'll be our domain. And our vertical asymptotes are going to be exactly these lines. X equals negative 1, because it's a value we can't have, and x equals 4. So we've done step 1. Step 2. Now we look at the function and we see that the degree here is 2, and this one here is also degree 2. So since they're both of degree 2, then we know that we will have a horizontal asymptote. And the horizontal asymptote will be given by y equals, and we look at the numbers in front of x squared here, which is 1, and the number in front of this x squared is 1, so we have y is equal to 1. So there's our horizontal asymptote, which is y is equal to 1. Alright, so far we've done the first step and we've done the second step. Next, we want to find the y-axis intercept by evaluating f of 0. So number 3, f of 0 is going to be 0 squared minus 2 by 0 minus 15 over 0 squared minus 3 by 0 minus 4, which of course is just 15 on 4. And so our intercept point will be 0, 15 over 4. Just a little bit shy of 4. Okay, so we've done that one. Next we want to find any x-axis intercepts by solving f of x is equal to 0. So this would be solving x squared minus 2x minus 15 over x squared minus 3x minus 4. And of course we can multiply through by the denominator. So as it mentions here, this is really just finding the zeros of the numerator polynomial p of x. And of course this is really just finding when x squared minus 2x minus 15 equals 0. And using our factored form, that implies when x plus 3 by x take 5 is equal to 0, which implies that x is equal to negative 3 and 5. So what are my points? They are going to be negative 3, 0, and of course 5, 0. So they're the x-axis intercepts. So we've done that. Now we need to determine whether the graph will intersect its non-vertical asymptote, y equals b. So we're talking about y equals 1 here. That's what b would be. By solving for f of x equals 1, so we need to look at x squared, so this is step 5, x squared minus 2x minus 15 over x squared minus 3x minus 4 equals 1. Okay, so this implies if I multiply through by the denominator function, I'll have x squared minus 2x minus 15 is equal to x squared minus 3x minus 4. Now notice that, because that's 1 times that, I can put the 1 there if you like. So really what we have is x squared minus 2x minus 15 equals x squared minus 3x minus 4. Now let's see if we can solve for this. So of course x squareds will cancel. Bring this 3x across will give me 1x. And if I put 15 across here, I will have plus 15, so that'll be 11. So it does actually cross this line at x equals 11. And of course if we want to find what the y value is, okay, so x equals 11, it's way off our graph by the look of it. And so what we need to do is have a look at evaluating this using this one up here. So this will be 11 plus 3 by 11 take 5 over 11 plus 1 by 11 minus 4. So the factored form is helpful here. So this will be 14 by 6 over 12 by 7. Okay, so 6 is let's go 2, and of course we have 2 sevens are 14, so this comes out to be 1 actually. Very good. Alright, so our point there is 11, 1 is where it's going to cross the line, the horizontal asymptote. And we're going to plot any other extra points, and what I tend to do now is I start putting our information on here. For example, we start putting the vertical asymptote, which is x is equal to negative 1. And let's label that equation. We also have x is equal to 4. And we used broken lines for the asymptotes. This is x is equal to 4. Alright, we have a horizontal asymptote y equals 1. Like so. Right, now let's put on our our y-intercept, which is 15 over 4, which is just a quarter shy of 4, so it's just about here, right there. We have our x-axis intercepts, which are negative 3, 0, and 5, 0. Okay. Alright, so you can see that we have points in this part of it, we have points down in this section here, and points down here in this section. Right, now, if I carry this point on a bit, we see that it crosses at 11, 1. So here's 9, 10, 11, 1. So it crosses about here. So clearly it's come around here, like so. Right, now when it comes to here, alright, this is an asymptote. This vertical asymptote is like a wall. So if I was travelling around here, I'd be trying to avoid the wall, so it would come down here like so. And it goes up here like this. Right, now what happens in here? Well, that's a good question. We need to look at some points in here and see what actually happens. So our sixth step is let's plot some points as necessary. For example, if I have x is equal to 1, what's f of 1? Well, that will be, if we look up here, f of 1 is going to be equal to 1 plus 3. The factored form is actually easier to work out. 1 minus 5 over 1 plus 1 and 1 minus 4. And so this comes out to be, we have 4 times negative 4 is negative 16. And here I have 2 times negative 3 is negative 6, so I end up with 8 over 3. So 8 over 3 is about 2 and 2/3, so it looks like it's about here. Okay, what happens if I have x is equal to 2? Well, maybe we can work this out fairly quickly now. This will be f of 2 then will be 2 plus 3 by 2 take 5, and we have 2 plus 1 and 2 minus 4, and of course this will come out to be 5 times negative 3 is negative 15. And we have 3 by negative 2 is negative 6. So we can see here this comes out to be, if we cancel by 3's, it's going to be 5 over 2. So that's 2.5. So it's coming down here more so. And of course if we do 3, x equals 3, then f of 3 will be 3 plus 3 by 3 take 5 over 3 plus 1 and 3 take 4. Okay, so we end up with 6 here times negative 2, which will be negative 12, and we'll have 4 times negative 1, which will be negative 4, so I end up with that being 3. So it goes through 3, 3, so it looks like it's starting to go up. So this gives us a picture here that it's going around here, and as it comes towards this wall, of course, it's going to avoid the wall. Same here, as it comes around here, it's going to avoid the wall. So we end up with that. Alright, now we have this one point here, so we should look and see what happens when x is equal to negative 2. Alright, so when x is equal to negative 2, alright, we're going to have f of negative 2 is going to be equal to negative 2 plus 3, and we have negative 2 subtract 5, all over negative 2 plus 1, and we have -2 subtract 4. So this is going to be, so we have a 1 here by -7, so that's a -7. We have a -1 by a -6, so that will be a +6, so it's going to be -7 over 6, which is -1 and a sixth. Okay, so this comes down here like so. So it appears that it's coming down here, and of course as it starts coming down here, getting closer to this wall, of course it's avoiding the wall, so it comes down like this. So clearly it's coming up around here like this when it wants to avoid this wall here. We had nowhere that it was going to cross the wall like on the other side, and there's our picture. And you can see here that we have indeed graphed this rational function fairly accurately based on these 6 points, and of course number 7 is actually sketching the graph.